All right, so we're going to be working on the movie ticket problem. And you can see that we have $12 for tickets, $8 for snacks. People can buy as much of either that they want. And what we want to do with this one is all day long people are making orders, and we're going to be telling them how much they owe, and then we're going to be keeping the information on how much they've ordered, and then at the end produce a report. So it says at the end of the day, so no longer when at the end of the transaction, now we're talking about the end of the day, the report will show this information. So I'm going to just go ahead and copy that and go into Notepad++. You can see I have the same problem here. And we're going to go down to output, and we're going to go ahead and paste it in, because just because we're at loops doesn't mean we're not doing the same thing that we should always do. So we have the number of customers is something we have to output. So in the past, I would do something like this, num customers, because a person would then, I'd ask how many customers and they would tell me, but now I don't know how many customers there are. We actually have to calculate that, which means we have to count the number of customers. If we picture the loop, each time we go around the loop and ask a person how many tickets they want and how many snacks they want, that's going to represent one customer. And then we're going to go around again. That'll be two customers, and around again, three customers. So that means that this right here has to be a counter. So instead of calling it num customers, I'm going to call this customer count. And that's probably the hardest part of this, is identifying counters and accumulators. So you're going to have to spend a lot more time on output, because if you get it wrong, then you're going to have to go back and fix a lot of stuff. So think about it as you come in. Anytime they want to count something, so here they want the number of something. Here we have the number of tickets sold. But since they can order as many tickets sold as they want, instead of being a counter, that's going to be an accumulator, because we're going to ask them how many tickets you want. They're going to say 10. So we don't want to just increment it by 1. We want to increment it at that point by 10. And we'll see that next. So this first one, number of customers, is the customer count. And then the number of tickets sold. So again, if you picture how this application is going to run, we're going to ask them how many tickets they want. And if they say 10, we're going to keep that 10 and then go around again to the next customer. And the next customer says they want 5. We want the number of tickets to be 15. That is a definition of an accumulator. So for that, we're going to call this an accumulator. So it won't be num tickets. It'll be, let's do ticket accum. So all accumulators are going to end with accum. All counters are going to start with count, and that's going to make our someone looking at our code, even us 6 months later, oh, I know exactly what I'm doing with that. I know exactly what I'm doing that. I'm accumulating things. All right, so the same thing with the number of snacks. Instead of it being num snacks, that has to be accumulated, because they're going to say, I want 3 snack packages, I want 2 snack packages, I want 1 snack package, and that's going to be 6. So we're going to call this snack, I'm not sure why that's over, accum, because it's going to be an accumulator. You're going to actually like counters and accumulators because it's the easiest math. Oh, that's snack packages sold. And now that we have the amount of money, so the amount of money collected for each. So we have tickets and we have snacks. So when they say for each, you have to be careful. That's not one place in memory. That's actually 2 places in memory, because it's going to be the money collected for tickets and the amount for snacks. So I'm going to call this ticket total. Actually, let's do total ticket, and this will be total snacks. And then they want the total money for all day, and that'll be the last thing. So that will be total cost. Now there's another thing they wanted in here. At the end of the sale, they want to let the customer know how much money they owe for the tickets and snacks they ordered. So we're going to have to do that calculation too. and that's going to be right here. Let's do that everything. So customer owes is another piece of math we're going to have to do each time we go around the loop. So here we go. We have all these right here, and none of these is going to be input. So I'm going to do Control C, Control V, and then put a space equals space, and then copy that, Control C, and then Control V, Control V, Control V, Control V, Control V, Control V. Okay, we also have our constants. And so we have the ticket rate, oops. Ticket rate is going to be equal to $10. As we've seen up here, we have two numbers. Whoa. I think I don't want that to be 12. I don't know why I said 12. That should be 10. It's 10 and 8. And then the snack rate is going to be equal to 8. There we go. So now we move down to here and we say, okay, well, we start with the bottom math because the bottom math is the easiest math because it uses stuff above it. So if I know how much money I've taken in tickets and I know how much money I've done in snacks, then this becomes very easy. The total cost is simply the total. Let me move this up a little bit. You can't see it. Total ticket plus total snack. Now you can see it. So see how easy that is? Doing the math this way, and it drives me crazy because students will see me after taking CPT 167, their Java class, and they're lost. Oh my, Mr. Brady, I don't know how to ever even start this thing. It's so complicated. I say, well, have you done a problem statement so that you can define your problem in a simple, easy way? No, because my instructor doesn't require me to do a problem statement. Well, that's why you're not solving the problem. All right, so total snacks. How am I going to know how much money I've taken in snacks? Well, if I know how many snacks I've sold and I know the price of that snack, then that's easy. All right, so it's going to be snack accum. That's how many snacks that we've sold. And we're simply going to multiply that by the snack rate. And then tickets the same thing. So if I know how many tickets, and that's going to be the ticket accum, and then multiply that by the ticket rate. Now I know how much I've done. See how that reveals itself? Now this is your favorite because these are always going to be the same. So snack accum is going to be the snack accum. It's whatever accum equals whatever accum plus whatever you're accumulating. And that's going to be the num snacks. You can say, well, we don't have num snacks yet. Well, someone's going to have to tell us every time they order how many snacks they want. So that's going to be input. So I can do Control C, Control V. And so ticket accum is the same thing. It's whatever accum equals whatever accum equals whatever we're accumulating. So it's going to be ticket accum equals ticket accum plus the num tickets. And again, someone has to tell me how many tickets they want. Control C, and I'll probably ask that first. So above here, Control V. Customer count. This is even easier than the accumulator because customer count, a counter is whatever count equals whatever account plus 1. So customer count plus 1. Whenever you use a counter, almost always you're counting the number of times you go around the loop. So you might think, oh, there's only one counter, but there can be many counters because if we are making decisions and we want to know every time we go around the loop, when do we go down that path for that decision, then each of those paths can have their own counter, and we'll see that in the future. So customer owes. So on this one, it's going to be, let's see, customer owes. And let's see what we want to do for that. All right, so how do we figure out how much the customer owes? Well, that's going to be the number of tickets times the ticket rate plus the number of snacks times the snack rate and add both those together. So that's complex math. So we're not going to do that for sure. So what does the customer owe? And that is going to be the num tickets times the ticket rate. No. And we're going to call that ticket cost equals that. Okay, so knowing that's how we're going to do the math, then I know that ticket cost plus snack cost, which we don't have yet, and that's the next thing we have to do. So what is snack cost? Snack cost is simply going to be the num snacks times the snack rate. Now we've done math similar to that before, but see, we're using the accumulator here. This is the math we're going to do for each customer. And this math down here, we're actually going to do outside the loop later on, but we need to get there first. So right now, I have covered absolutely everything. So we have our total problem statement completed, except for our scope. Ticket and snack rate doesn't change. Unlimited tickets and snacks. And the reason why I'm going to verify that is that if they say, well, no, you could only sell 400 tickets a day, then I'm going to have to put that into but in these ones we have unlimited. They never sell out, so we don't have to worry about that. And only one type of ticket and, well, only one type of snack. So I need to ask that question so they go, well, no, we have children ticket, adult tickets, senior tickets, military tickets. Oh my gosh. So this is going to make it much more complicated, which is why we made this very simple for you. You can see it's complicated enough, making it simple. But we're going to verify these to make sure that the scope we have is correct. All right, on to flowchart.